For decades, the industrial enterprise relied on steady, incremental efficiency gains to protect its margins. Today, those traditional methods of optimization yield diminishing returns. The machinery of marginal improvement has stalled. Mid-sized manufacturers face a structural deficit against global competitors. Closing structural gaps requires replacing the underlying logic of those workflows. A common assumption is that industrial firms must enter the trillion-dollar arms race to build foundation models, competing directly with US and Chinese tech giants. Foundation models demand massive GPUs, boundless data, and billions in capital. But the German Mittelstand can bypass this arms race entirely by dominating the application layer. We fuel this with 4 asymmetric advantages: proprietary data, domain knowledge, applied research, and decades of physical engineering expertise. Generic large language models lack grounding in physical manufacturing realities. Feeding highly specific, proprietary engineering data into targeted AI models creates a deep economic moat. Weaponizing existing engineering excellence through targeted agents makes the global foundational model race irrelevant to local P&L success. Moving from macro strategy to operational execution requires answering a specific question. How does a traditional manufacturer integrate this capability into its existing structure? This architecture centers on a 24/7 AI lab. Effective agents aren't built in a vacuum. They resolve exact friction points reported by the workforce. Within days, the lab pushes custom prototypes back to the shop floor for real-world testing. Domain experts carefully review and validate the AI's output before it is permanently hardwired into the company's systems. Continuous value extraction from operational friction replaces the cycle of top-down boardroom mandates. We can ground these AI concepts in a deeply established framework, DIN EN 12973, the standard for value management. This 9-step roadmap illustrates the fatal flaw of traditional value management. It is a highly manual, interdisciplinary slog that ties up engineering resources for months before yielding actionable results. The core equation is value equals functional utility divided by lifecycle cost. Agentic AI automates this, enabling retroactive value analysis. The explicit goal is sanitizing legacy product catalogs by aggressively driving down that lifecycle cost variable. A dedicated agent systematically correlates a component's functional utility against its true manufacturing cost. It scans millions of data points to expose systemic overengineering that human audits miss. Once the analysis is complete, the agent generates specific recommendations. It suggests cheaper alternative materials and standardizes component usage, ensuring cost is reduced without sacrificing functional quality. By stripping dormant costs out of the current portfolio, retroactive VA acts as an immediate liquidity engine, freeing up capital to fund future innovation. Fixing the past generates immediate cash flow, but protecting future margins requires the second horizon, proactive value engineering. This bar chart highlights the most dangerous blind spot in manufacturing. Up to 80% of a product's lifecycle costs are permanently locked in during the design phase, long before a physical prototype is built. A proactive agent integrates directly into the engineering team's CAD and ERP systems. It acts as a real-time financial guardrail while the engineers are still drafting. As the design takes shape, the agent calculates internal manufacturing costs down to the cent and evaluates complex make or buy decisions on the fly. Over-engineered designs are halted before they ever reach the tooling phase. Once the core operations are optimized, the system deploys the third horizon, strategic value innovation. This graph maps a traditional value curve, where companies compete on identical, established industry metrics. The strategic agent interrogates these metrics, identifying legacy features the industry obsesses over but customers find irrelevant. By eliminating those and spiking investment in high-value utilities, it charts a completely new trajectory, mathematically constructing a blue ocean market. Integrating all 3 horizons transforms agentic AI into a mathematical engine for proactive market dominance. The technical architecture is sound, but executive skepticism remains high for a clear reason. The vast majority of enterprise AI initiatives die as expensive, useless pilot programs. Companies fall into 3 specific traps. They deploy uncoordinated tools that cause knowledge drain, they get stuck in endless consultant-driven analysis, or they paralyze their IT departments with bloated automation integrations. This 5-phase roadmap details the structural countermeasure to those traps, a tightly scoped 30-day AI-first sprint. By week 3, the focus forces the agent into live operation. It bypasses bureaucratic paralysis by demanding a measurable impact on the profit and loss statement immediately. Speed of deployment and highly targeted integration consistently outpace massive theoretical IT overhauls. One final barrier prevents full industrial adoption: the severe risk of leaking proprietary CAD files, supplier contracts, and financial data into public external AI models. This architecture relies on a localized knowledge graph. It physically isolates and networks the company's intellectual property within a sovereign, secure vault, severing the need to share sensitive data with third-party cloud environments. This ensures absolute data sovereignty, meeting the strict compliance standards of GDPR, critical infrastructure regulations, and rigorous internal audit protocols. Synergizing these 3 agents creates an interconnected system. The retroactive analysis sanitizes the past, the proactive engineering protects the present, and the strategic innovation secures the future. Autonomous value management shifts competitive advantage from quarterly board reviews to real-time, systemic execution.